So the curve y is equal to x square root x minus 1, y is equal to 0, y and x is equal to 5. The enclosed area by these three is revolved around y, the straight line y is equal to 3. We need to find the volume that is generated using cylindrical shell method. So yeah, this one will be something like this. It will start at x is equal to 1. So that's there, and then x is equal to 5 here, which is the other straight line, and then y is equal to 0, which is the x-axis, and this one is y-axis. Now the enclosed area, this point will be x is equal to 5, this one will be, if x is 5, y will be 2, so that will be 5 and 2 here, and this is of course 5 and 0, this point. So this thing is revolved around y is equal to 3, which is the straight line. Y is equal to 3. It should be maybe a little above because this is 2, so 3 should be a little above, but anyway, so this is revolved around, this area is revolved around that. We need to find the volume that is generated using cylindrical shell method. So first let's take a small section here, maybe a different color. So let's take a very small section here which is of thickness dy, and this height, we can say the volume that will be the shape that will be generated will be something like this, cylindrical shell, like that. So this is our dy, but we are talking about the height. Height will be, this is 5 here, and this one is 1 here. So the height will be, h will be 5 minus x, because any point here, any point, let's say here, it will be 5 minus x, because this is x and this whole thing is 5, so this much is 5 minus x. Now x is, we will convert it into y because we are, our variable is y, so x is, of course, from here, since y is equal to square root x minus 1, so y square is x minus 1, so x is y square plus 1, so that will be y square plus 1, so which will become 4 minus y square, which is height, and r will be, of course, this one, the distance from here, it will be, this whole full distance is 3, so, and this distance, this much distance is y, so it will be 3 minus y, so r will be 3 minus y. So now that we know the r and h, our surface area of the cylindrical shell is 2 pi r h, and the volume will be multiplied by dy, the thickness. So everything has to be in terms of y, and the limits will be in y, so this will be 0 and this will be 2, the lower will be 0 and upper will be 2, so 2 pi outside, 0 here, 2 here, and r is, as we saw, 3 minus y, and h is 4 minus y square, and this is dy. Now we have to integrate this thing. So 2 pi integration 2 here becomes 12 minus 4y plus 12 minus 4y, then minus 3y square, and then plus y cube, that's dy here. Now we integrate this thing, so it becomes 12y minus 4y square over 2 minus 3y cube over 3 plus y to the power 4 over 4, and 2 0. So that will become 2 pi here, and 12 times 2, sorry, 12 times 2 minus 2y square, so that will be 2 times 2 square minus y cube, that will be 2 cube, and then finally plus this will be 2 to the power 4, which is 16 over 4. So that's it. So 2 pi here, 24 minus 8 plus 4, which is 28 minus 16, so that's 12. So 24 pi, that's the total volume, and unit is cubic unit. So that's the volume that is generated of the cylindrical shell.